Hello everyone, my name is Viraj and today we'll be looking at the 15th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So I've moved on to my sheet, 1000 rated and 15th problem, black and white stripe. Let's read this very short problem. You have a stripe of checkered paper of length n. Each cell is either white or black. What is the minimum number of cells that must be recolored from white to black in order to have a segment of k consecutive black cells on the stripe? If the input data has such a k segment of consecutive cells already existing, then you can simply print 0. Alright, so let us quickly generalize this problem. Very short and simple problem. Now let's start off by saying that there is a variable n and there is a variable k. Then there is a string s that has s1, s2, S3, S4, so on till Sn letters, and every letter is only either a white or a black, as in W or P. Now what is N? N is of course the size of the string. And what is K? We'll understand. First, what has been said that there has a par or operation that you can perform, that is you can change a color from some color to something else. Let's say white becomes black or black becomes white. Now they are asking you that how much minimum number of operations you have to perform like this so that you are able to come up with a k-lengthed continuous segment of black values in this string anywhere possible. For example, if let's say I say k is 3, then I am looking for any 3-lengthed segment which has all black. For example, S2 to S4, I'll talk about this. If I say I want to make S2 to S4 all black, I have to say that how much minimum operations do I do to actually create all black in this segment. Now, this is possible for this one. I can do this for any other segment. Of all such permutation combinations, I want to figure out what is the lowest possible operations to actually achieve a k-lengthed segment of all black. Okay, I hope this part is clear. Let's quickly understand an example, and I think this is going to be much easier. Let's say I pick up the first test case only. So you have 5, 3, and then the string is BB, and then you have W, B, W. So basically you're looking for 3-lengthed segment over here. This is k value and n value is this. So let's say I pick up this segment right over here, and I use my power to actually change this W to a B. Now I have a 3-lengthed segment of all B's. And how many operations did I do? Only 1. So I know that the answer is 1. Now remember, I'm just looking for any k-lengthed segment. I'm not asking make all k-lengthed segments like this. Any k-lengthed segment that you're able to create, just figure out what's the best answer possible. Now answer for this is 1. You can argue that maybe you would have picked up this segment over here, WBW. If you pick up this segment over here, what would have happened is to create a segment of 3 length over here with all blacks, you will have to change this to B and also this to B. So in this case, your operations would have been 2, which is higher than 1. That means I would have preferred to actually take up this segment. Okay, I hope this part is clear. Arguably 1 is the answer. Let's go back. Yes, 1 is clearly visible. It is the correct answer. Okay, so I hope the problem has become clear. You can pause the video. It's a very simple problem. Again, stating the same fact, just make any k-lengthed segment of all blacks, and doing so, figure out the minimum operations. All right, let us look at the expected time complexity that is required in this problem. So you are told that one test file will run in 2 seconds. So I can write this, one test allows 2 seconds, that is 2 into 10 raised to 8 operations. Right now I have been told that n is given in 2 into 10 raised to 5 order. Even before that, there is a test case variable actually in 10 power 4. Although since this has been said that sum of n over all test cases do not exceed 2 into 10 raised to 5 order, so I can just have a small comparison with n and forget about test cases. N being in 2 into 10 raised to 5 order promotes a solution like O of n. Yes, that's possible. If I create n log n solution also, that's also possible. A little larger, n square root n also possible. But as soon as you go in this n square boundary, that's going to be a problem. So come down up to constant solutions, everything is good to go. So solutions like these are promoted. If you're able to think up arguments or solutions in this order, that's fine. But n square or above is not correct. And this is my expected time complexity. Very fruitful. since now I'm not looking for a brute solution, and this is clear by this discussion, nothing in n square, everything below that. Okay, let us move on to the idea in the problem. Now, first of all, let me question, what are you trying to do? Any k segment of length black? So let's generalize. Let's say there is some segment S1, S2, S3, S4, so on till Sk. Okay, this is a k length segment. I just pick up k letters, continuous letters from the string. Now, if I ask you, just for this segment, how much minimum operations do you do to convert this to all black? This is very obvious and very intuitive. If this segment has, for example, 4 blacks and it has 3 whites, just for sake, let's say it has 4 blacks and 3 whites, then converting it to all blacks means these 3 whites should convert to blacks. So if I ask you, for this segment, how many operations do you perform? You will say, I'll perform 3 operations. Those 3 operations will be converting these to 3 black, hence making overall as all black. Now remember, this is for 1k lengthed segment. Now let's generalize once more. The string actually looks something like this. Let's say S1, S2, S3, S4, S5, S6, and let's say S7. Let's say I have a 7 lengthed string, and let's say k is equal to 3. So what are the 3 lengthed segments that I have? I have this S1 to S3, S2 to S4, S3 to S5, S4 to S6, S5 to S7. I have 5 segments of 3 length. Now for one segment, I know what's the answer. For one segment, the answer is simply calculating the number of whites that fall in that segment. I need to figure out this answer for all segments. Maybe from here, this is operation 1. Maybe from here, this is operation 2. And so on, so on, so on. Maybe from here, this is operation 5. Now, I have 5 segments. Everybody gives their own answers. Which would I prefer? Of course, intuitive, the minimum of these. So minimum of operation 1, operation 2, so until operation 5 will actually tell me the answer, because that would mean which segment should I actually choose to make it all black. Let's say OP2 is the least value in this. That would basically mean that you would try to select a segment of S2 to S4, and when you make it to all black, you will use the least operations of switching white to black, hence overall saying better answer or the best answer. And this is the whole idea. Let's write this down in argument form quickly. Out of all k length segments, the one which has lowest number of white cells is the answer. Okay, I hope this part is clear. Great. Now we have understood the argument. Let us actually see how do we implement this. Now, we know that a very brute solution can come to mind. That is, you can run some sort of a for loop logic, and this loop can control some sort of an I pointer. Now, from this I pointer to a I plus k sort of, you can say, segment, you can just count the number of bytes. So to do that, you will again utilize a for loop, and this would basically control the counting part inside this k lengthed segment. So let's say from I to I plus k, something like that, you will count, okay, how many number of bytes came. And this counter might be saved in some C value, and then this C value outside this for loop can be minimized. Overall. Minimized with some answer variable that is global. This is a pseudo rough idea. But the problem this creates is this is an O of n order. And inside that you have again a loop which is roughly an O of n order again, because the windows can actually go to a larger size. So you have created a solution that runs in O of n square roughly, which is TLE. I don't want that. We just discussed that in expected time complexity. So I need something better than this. So let's analyze. The components are n into n. The outer component n is coming from going to every index I, so that I can make a window from I to I plus k. So I to I plus k window. And this inside component is actually calculating the white cells from I to I plus k. Can I optimize this part? No, I don't think so. I need to go to every index so that I can actually take up a window size or take up a segment size. But n over here is optimizable. I'm repeatedly calculating inside a fixed window length what is, or you can say from a range of L to R, I to I plus K, whatever you can understand from here, what are the number of white cells. If I can better this logic, I think I can optimize my overall code. And the idea now stands implementation wise is how do you get some answer from an L to R range. And questions like this are very, very obvious and intuitive. They are solved by various methods. We'll take up one of the most common methods that is called prefix array or prefix array sum, whatever you call that. Okay. What is this logic? I will define an array of exactly size n, that is size of the string. Let's say this is of the size 5 and I had a 5 length string. I will say that this array's ith index will represent number of white cells till ith index. Now, why does this help? Let's say the number of white cells till here is 0. Then over here it's 1, then again 1, then 2, then 2. For example, something like this. Corresponding to this, let's quickly draw the string also. It would look something like this. You have black, then white, then I think black again, and then white, and then black, something like this. Now, if I have to ask you quickly, what is the white cells that fall, let's say from this portion to this portion? You can actually do this quickly by prefix array. How? Calculate the prefix array value till this part. That would be 2. And from that, if you remove this much portion, then that is actually this segment's answer. So it would look something like this. Get the answer till here. From that, subtract the answer till here. And that actually points to this red piece of segment. What will that value look like? This is the value 2. And then this is the value 0. So 2 minus 0 gives me 2. And this means there are 2 whites that fall in this segment. And cross verify, yes, there were 2 whites that fall in this segment. Now, by this logic, by this implemented technique, how do I actually get the answers? Remember, I was looking to get white cells between I to I plus K. That was an L to R range. Now, this overall prefix sum idea can be pre-computed. It is before the outer for loop where you actually go inside and go to every segment. So that means this inner for loop is now going to become constant because you will just have to quickly call I plus K and I as a segment from the prefix array, get those values, get the difference, and minimize that with your answer. Okay, I hope this helps. I hope this makes sense. Let us quickly see the test case once more so that we are able to work out our idea. So we have BB, you had B, B, W, B, W, and K over here was given 3. Let's draw a prefix array for this. So up till this location, 0, then you have 1, then 2. Now let's consider all 3 lengthed segments. So this is 3 lengthed, this is 3 lengthed, this is 3 lengthed. Let's figure out their answers. Answer from here comes by 1 minus, before this, you can say this is the value 0. So you can say 1 minus 0, this is 1. From here, what do you get? You can say 1 minus this 0. So this is 1 minus 0, again 1. And from here, what do you get? 2 minus, you can say this 0. So this is 2 minus 0, that is 2. So clearly observable that yes, from this segment, there was 1 white. In this segment, there was 1 white. And in this segment, there was 2 whites. Now, out of these values that popped up, 1, 1, 2, let's take the minimum. This is 1. And yes, 1 was the answer. All right. So I hope this part is clear. Again, this is a very, very famous algorithm. So I would highly recommend you pause the video and understand this fully if you're seeing this for the first time. Other ways, by the way, to solve this problem would be something known as sliding window. That's a second implemented technique you can perform over here. So if you actually solve this once using prefix sums, just for practice purpose, you can do this once more with sliding window technique. Also, it has the same idea, same crude method. All right, I hope this part is clear. Let us actually quickly jump to our implementation in terms of code and see how do we figure this out. Just how I showed you pseudo, that is what we are going to do. Take the input of t, then n, k, then the string s, then I'll create a prefix array. Now n plus 1 size, so I've done a 1 base indexing over here. Why? Because the 0th index was having a value 0. 0th index over here basically means anything before the first letter. So that has 0, no whites till that location. I'll run a loop from 0 to n. Now, prefix array is 1 based, so I would perform I plus 1 is equal to the previous plus s of I being equal to w or not. So this condition returns 1 or 0 accordingly. As this happens, prefix of I is the previous result, gets added with either a 1 or a 0, and a prefix of I plus 1, that's the next value, gets automatically updated. So this creates a prefix array for me where every ith index in 1 based order is actually showcasing number of bytes till that location. Now I have a minimum cells, that is actually my answer that I have. Start off this with int max. Now I want a loop to go from 0 to less than equal to n minus k, because I am looking for I to I plus k as a window. So I don't want to land at an index where I plus k doesn't exist, right? So I would want to land at somewhere where I plus k is still plausible. That means I need from my main size of length of string minus k to be the last place where I rotates. So you can say I0, I less than equal to n minus k, I plus plus. Now the difference is prefix of I plus k, that is the after portion. From that, remove the previous portion. So from this longer part, remove a smaller segment, and that gives you the middle segment, the I to I plus k range that you're looking for. This is actually the number of cells in that segment. Minimize that with your main answer and come out of the loop. This will give you the correct answer over all segments. All right. I hope this is clear. What is the time complexity? This is n order roughly to take the prefix array. This is n order again to take the input of the string also. So you can consider this part also. And then n order over here also to figure out the answers, because everything inside that was constant. Time complexity boils down to O of n order, which is O of 2 into 10 raised to 5 order. And this is very nice. This is something that we of course would want, and of course runs. Space is O of n again, O of n from string also, and you can say n from prefix array also. So that's 2 into n, but you can consider n only. So I think that this problem is clear. Idea of course is reusable. Prefix sums was the main key over here. Of course, look for problems where range or sort of queries on some range is asked from L to R, and there 99% chances are prefix sum idea gets repeated there. Okay, so I think that is all that is there in this problem. I hope you like the video. Thank you for watching.